Um, so next we're gonna discuss the second method. So what we call the washer method. So washer method. So what is the difference between the disk method and the washer method? So let's talk about the disk method. Disk method. So what's gonna happen? So for example, when you look at the previous like some of the problems that we did before, so for example, let's say we can rotate about the x-axis, that's the curve, so it's gonna generate something like that. Okay, and then when you look at typical cross section, it looks like a disk. See that? This looks like a disk. So you see everything there. So that's the disk you see. And then your area was simply pi the radius squared. In this time the radius is y coordinate, so it's a pi y squared. Okay, so that's why it's called a disk, because this is a area of a disk. Now we have the second method, what we call the washer method. The washer method. So now how to figure out what method we can use. So let's look at a typical situation. So let's say you have not one curve, now we have two curves. So that's one way to figure out this is not the disk method. You have two curves. Okay, so let's say let's look at this curve. This is y equal square root x, and also let's look at a line like that. So this is the line y equal x. Okay, so now what we're gonna do, you know that those two lines gonna meet at a point. You can see when you put x equal 1, they are equal, right? Square root 1 is 1, so they are equal. So so your region, so this is your region. So your region is this. That's your region. And what we can do, we can rotate this region about the x-axis. So let's say we can rotate about the x-axis. Okay, this should be given, because we don't know there are a lot of axes. Now what's going to happen when you rotate? Now you can see just gonna create a solid. It's gonna create a solid, but that's gonna look like this now. Okay, so that's that, and then this part gonna go there. So so this is how your solid looks like. So that's the opening, and then now as before we're gonna cut into cross section. So if you cut into cross section in the xy plane, how it looks like. So it's gonna see part here and part there. You see that there's a part missing inside. So so you're gonna see a part here. If you pick the middle point, this is how it looks like. So this is how it looks like. So that means so there's a hole in the middle. So go like that, and then it's gonna look like this on this side, and also it's gonna go like that. It's gonna go like this. Alright, so so, and then also there's another line going like that. So this is how it looks like when you cut it. So it's gonna look like that. So that's the part you're gonna see from one side. And then if you look at from the if you look at like from this side, so how it looks like is this. You're gonna see a big circle, inside you see another circle. So that's why we call it a washer method, because it looks like a washer now. So there are two radii. So there's a larger one, and there's a shorter one, right? So there are two radii now. So the two radii, one is y2, the big radius from the center. This is the axis, right? So it's a y2, and there's a small one also, y1. So because of those two, and then what you try and do, so you can see it. So that is the one we have. So there's a hole in there. So that's it's a washer. Okay, it look like a washer. So that's why we call it a washer method. So what's gonna happen? So we can slightly modify our formula. So so if you look at the formula, what's gonna happen now is so the area at the x position is simply you're gonna find the larger area. So it is the outer one. So I'm gonna write it like this instead. So let's write it like that. So let's say so it's ax, which is pi, the outer radius squared, that's the area of the larger one. It's going to give the area of the larger one, minus pi, the inner radius. So that's that one. That's that one. So we're going to subtract that part. Then it's going to give you the good one, right? So what we normally do is we can write this like that. We can write this as pi big R squared minus pi small r squared. Or if you take pi out, it is large r squared, small r squared. It's easy to remember. So larger one and a smaller one. Okay, so that means you're going to have a slight modification to your formula. So the volume using the washer method is simply whatever the limits. So I'm going to say a to b pi large r squared, that's outer radius, minus the small r squared. Okay, so I just write dx, but it can be dx dy depending on what axis we're going to pick. So that's the formula. So you can see that it's a slight modification, but new formula. And I need to give you some warning. So we have r squared minus r squared. This does not equal to r minus r squared. So this is not the case. Okay, so that means you have to simplify them separately. It's not equal to this. You can write it r minus r squared, because some students make mistakes like that and lose a lot of points because of this. Okay, so yeah, so as the method, so this is the method. So it's not that difficult. So what you want to do is you define what is the outer radius and what is the inner radius, and then you after you get that, just plug in as you did using the disk method. And what we call the washer method, there's a hole in the middle. So you need to find two radii right now. So we can do two problems, maybe like three problems. One rotate about x-axis, and then also like maybe some different axis, like x equal -1 or y equal 2, something like that. Okay, so I'm going to do three problems like that. And also we do one general problem, like what if you don't have a rotation but just some different solids. Okay, so let's do three problems right now. Okay, so the first one, I think this is example number 4 if I continue from the previous section. So let's do, so it's example number 4. So let's say the region R region R enclosed by by the curves y equal x and y equal x squared is rotated about the x-axis. Find the volume of the resulting solid. Find the volume of the resulting solid. Find the volume of the resulting solid. The region enclosed by the curves y equal x and y equal x squared is rotated about the x-axis. Find the volume of the resulting solid. So always it's a good idea to graph the corresponding curves, and also in the exam you're going to get some points for doing it, because there's no way you can do this without considering these graphs. So what is the first one? Y equal x. So y equal x looks like that. It's just y equal x, and then we have y equal x squared. Y equal x squared goes like that. Good. So then we know that at 1 they meet each other, at 0 and 1, and if it is not very clear, so what you can do, you can set them equal. So in general what we do, we set them equal and then solve for the points. For example, I'm going to show you the work here. So let's say for intersection points, we don't do that here because it's very clear, but sometimes you have to do that for intersection points. We did this one in the area problem also. Remember, with the area problems, in that we did this. We're going to set them equal. So we're going to say x squared equal x. So we can set the two curves. One is x squared and x. Set the equation and then bring it to one side and factor it. And this is going to give you x equals 0. This is going to give you x equal 1. So those are the corresponding x values, and then you can find the corresponding y value by plugging into the equation, and you can see that that's exactly clear, 0 and 1. Okay, so this is what we normally do. Okay, now so we have everything we need, and also now what we can do, so and it says that it's going to rotate about what axis? The x-axis. So you need to draw that. So that's the rotation. Okay, it's a rotation. It's about the x-axis. So if you rotate about the x-axis, what's going to happen? This part gonna jump to the other side. So let's go like that, and then this one go like that. Okay, so that's the that's what happened. And then you can also mark the typical cross section. So it is like that and like this. But when you do we only need the radius, so we only need one side, so that's the x, and then we're gonna mark the smaller radius r and the larger radius big R. Okay, so it's easy to use small and large r. Okay, so and then this curve is y equal x, the other curve is y equal x squared. Okay, good. So the next step would be just to find those numbers. So let's find them. So what is the smaller r? Small r is the y coordinate of the bottom curve, so that's x squared. And in the exam I'm gonna give you points for the graphs drawing like this, and also you're gonna get points for finding these things. Okay, so make sure that you follow these the methods, because we do that just to make sure that you get the right answers, because sometimes what happened, we think like, we understand the question, but at the end, no, it's not the case. So we make sure that you understand the technique correct. So what's the larger radius? That's the y coordinate of the top curve, which is x. Okay, so you find the two radii, the limits going from 0 to 1. So that means so we can find area. So it's ax, which is pi big R squared minus pi small r squared, and then which is pi big R is x squared, big R is x, so it's x squared, pi small r is x small x squared. So if you simplify this a little bit, you're gonna get pi x squared minus pi x to the 4th. Okay, so let's simplify that first, and then let's write the formula. So the volume v is limit going from 0 to 1 ax dx, so 0 to 1, and then so this is pi. If you take pi out, you get x squared minus x to the 4th dx. Where is it integrate? So it is so the integral is pi x3 over 3 minus x 5 over 5, and then the limits are 1 and 0. so you get pi. If you plug in 1, you get 1/3 minus 1/5. If you take the common denominator, is 15. So 5 minus 1, so it is 2 pi over 15 unit cube. Okay, so that's the volume of the solid generated by rotating those two curves. And you can see that so how it looks like. Actually, I can draw this one like extra figure. So those are the outer lines, and then you can see, you only see this corner here, but inside it looks like this. Inside looks like that. So this part is the solid part. Okay, this part is the solid part. So if you are in engineering, this is very useful, because you might need this kind of special situations to do certain things when you do like turbine, rocket science. You need these kind of special figures as vowel, like a valve. Okay, good. So so you can see that in the washer method, the big thing is you need to figure out how to find the two radii, and once you understand how to find the two radii, it's not that difficult. You just to plug in and simplify, so it's not that bad. Okay, that's the whole problem. So please expect something like this in the exam on Wednesday. Okay, so let's do a different example. Let's try to rotate about a different axis. Okay, different axis. So the next example, I think example number 5. So so find the volume. Find the volume of the solid. Find the volume of the solid obtained by rotating the region in example 4, just the previous example, about the line y equal to, okay, about the line y equal to. So it's the same region, but we have a different axis of rotation. So let's see how it looks like. So your two curves were one equal y equal x, that's one. The other one was y equal x squared. So those are the two curves. They meet at 0 and 1. Now what we can do, we can rotate this about the y equal 2 axis. So that's the y equal 2 line. So you can rotate about this line. So you can rotate about that line. So this is y equal 2. Okay, so instead of x we have this line. So if you rotate about that, what gonna happen, it's gonna generate equally distance from this axis of rotation. So that means so this is 2, so it's gonna jump to 4 here, and so this at 1, so it's gonna jump to 3 here. Okay, so that means your new, so it's gonna be like that. So this is what happened, right? So if you draw the complete solid, it may look like this. So we have this part, and there's a hole here, and the other part on this side. That's how it looks like. So again, now when you drew the cross section, so again drew the cross section. So that's the so we're going to cut perpendicular to the axis of rotation. So it's going to look like that. Again, now your goal is to find the larger radius and the smaller radius. So so this is the larger radius, this is the larger one, and that's the smaller one. Okay. So you can do it up there or even down there. So it depending on how you want it, you at the end you're gonna get the same answer. But I'm gonna use the numbers from down, so it's just to make it easy to work with. So you can see, so that's again the smaller radius, easy to work with from the bottom, and that's the larger radius. Okay, so that part is clear. Okay, so let's find the radii. Okay, so we know that what are these curves. This curve is y equal x squared, and the other one was y equal x. So so what is smaller radius? Smaller radius means that smaller gap. So what is that? Smaller radius is the total height. In this case the total height is 2 minus the y coordinate. See, so you can see that so this is 2, this is 2. So if you subtract the y coordinate to the top curve, if you subtract the y coordinate to the top curve, you're gonna get the smaller r. So the smaller r is, so if I call it equation 1 and 2, curve 1 and 2, so what's gonna happen, the small r is 2 minus y1, right? So that means 2 minus x. The large radius is again 2 minus, what's the large radius? You subtract the bottom one, y2, which is 2 minus x squared. Okay, so 2 minus x and 2 minus x squared. Okay, so we have the two radii right now. Now what you want to do, you want to use the formula and simplify it. Okay, so the volume V is, okay, what are the limit, what's the variable? You can see the disk is so this is the disk, so it's moving in the x direction. It's a dx problem. Okay, so it's a dx problem, so that means the limit x limit, so 0 to 1, and then pi larger radius minus smaller radius dx, because it's moving in the x direction. So in the washer and the disk method is moving along the axis. So see, so the axis is like horizontal, so it's moving on the in horizontal direction, so dx. Now we plug in here, so it is 0 1 pi. What's the larger radius? 2 minus x squared squared, right? Minus small radius 2 minus x squared dx. So it is now what we're going to do, we're going to simplify. If you distribute, you're going to get 0 1 pi. Let's distribute. So what do you get? You're going to get x to the fourth. Do we get any x squared here? You're going to get negative 2x squared here, and you're going to get x squared there, subtract. So you're going to get negative, actually you get 4x squared. Negative x squared is negative 5x squared. And then you get a 4 and a 4 subtract, it cancel out, and you also get a x term here, so you're going to get negative 4x with the negative sign, positive 4x. Okay, that's what you get, and dx. And then so you're going to get, take pi out and integrate, so you're going to get x to the fifth over fifth minus 5 third x cubed plus 2x squared. Okay, so we have 1 and 0, and when you plug in 1 and 0, you end up getting pi 1/5 5 third plus 2. Take the common denominator 15, and if you get common denominator 15, you're gonna get pi over 15 multiplied by the missing term, you get 3, and then you're gonna get 525 25, and then 15 times to 30. Okay, so and you're gonna get 8 pi over 15 unit cube. Okay, so that's the whole problem, and you can see that you rotate about a different axis. So here we rotate about the y equal 2 axis. Y equal 2 axis. It's the same region from the previous example, but you rotate about the different axis. The only thing that you need to think about is how to find those radii. Okay, once you find the radii, things are easy. So we do one more example of this type. So the next example, so this is example number 6. So find the volume of the solid. So find the volume of the solid. Find the volume of the solid obtained by find the volume of the solid obtained by rotating the region, in example 4 about the line x equal -1. Okay, so what we have is the same problem, but now you rotate about line x equal 1. So so let's see what's gonna happen here. So we have the two curves. This is one curve, that's the other curve. So this is y equal x, this is y equal x squared, and we have 0 and 1. So now what we're trying to do is, you're going to rotate about what axis? So the axis is -1, so it's here, that's the axis. Okay, so that's the axis. So so this axis x equal -1. So what's going to happen once you rotate it? So this part gonna go equally distance from the other side. So that means this is 0, so that means negative 1 is going to go to 2, negative 2 actually, negative 2 and negative 3. So it's going to go between those two numbers. So that means 1 going to go like that. So that's 1. The other one is going like this. So that's the solid we're going to get. Okay. Like that, and then this is like that. Okay, so that's what happened. Now again, what you need to do is we need to find the distance from the axis. We're going to find the distance from the axis. So so that's a typical cross section. In the exam I will ask you to draw a typical cross section. Okay, so you're going to get some point for that. So that's the typical cross section. That's the only part we're gonna see. Yeah, we're gonna pick the middle point, and then so we have two radii. This is the larger radius, and that's the smaller radius, smaller. Okay, so you have the larger radius and small radius. Okay, so let's find them. So what's the idea? Again, we already have the two curves. Now what we need is the x coordinate. So we need the x coordinate, one on the shorter, so I'm going to say x left, and we also need the x coordinate for the larger one. I'm going to call x r, right and the left. Okay, one in the left and one in the right. So so let's find the radii now. That's the critical part. So you can see this distance is how much? The distance is 1, right? It's not negative 1. The distance is 1. So so what's going to happen? What's going to happen? Small r is, we know that it's a 1 plus the one in the left, xl, the x coordinate of the left curve. So 1 plus, what is xl? So you have to solve for xl from the left curve, which is y equal x. That's the left curve. So that means it is y, the y coordinate. Okay, it's just the y coordinate because x equal y. Okay, actually I can write them. So this gonna say x equal y, and this one say x equal square root y. Right? Good. So also one is done. The other one, big R. What is a big R? It is again 1 plus x right. What in the right curve? The right coordinate. Okay. So again, these are only x coordinates. Okay? X coordinates. So it is 1 plus, but xr is square root y. Okay, xr is square root y. Okay, so we find both of them now. Now we can find the volume. So the volume is okay, the volume is so let's think about the limits. We need to think about the limit. So you can see that this is a this is moving along the moving like up and down, the disk moving up, the washer moving up down. That means the dy problem. That means we need the limit of y. So what are the limit of y? It's going from 0 to 1, 0 to 1. Okay, 0 to 1. Limit of y are 0 to 1. And this is again a dy problem. It's not dx, it's a dy problem. Okay, the thickness is along the y direction, so dy. So it's 0y ax dy, but ax is pi r squared minus r squared dy. So let's plug in. So 0 1 pi big R is 1 plus square root y squared. Small r is 1 plus y squared dy. And then what's going to happen? We can simplify. If you simplify, what you get? You're going to take pi out, 0, 1. You simplify, you're going to get 1, 1 get cancelled. So you're going to get 2 square root y from the first one. And then you also get a y term here, negative 2y, so this is a minus y. And also you're going to get y squared. So those are the terms. This is after you distribute and simplify. Now you're going to integrate. If you integrate, you're going to get pi. You're going to add 1 and divide. So you're going to get y 3 half divided by 3 half. That means 4/3 y 3 halves minus y squared over 2 minus y 3 over 3. You're going to integrate from 1 to 0. And if you plug in 1, it's pi, what do you get? 4/3 1/2 1/3. Very easy to simplify because 4/3 1/3 get cancelled. You get like 1 out, so it's a 2/3. So if you simplify, you're going to end up getting pi halves. Okay, pi half. So that's the volume of the solid. And make sure that you do all the work when you do this problem in the homework, because in the exam you only get 10% for the final answer, so everything else gonna go to the rest of the work. So for drawing it correctly, you're gonna get some points. Finding the radii, you're gonna get another some points. So probably like 50% goes to those two, actually, drawing it correctly and also finding the radii, and the rest of the 50% goes to the other part. Okay, so yeah, so it's like about 50% goes here and the other 50% goes there. So that's how kind of we do it. So make sure that you're going to show the work. Okay, good. So let's do one last example. So we can see, so the last the example is, let's talk about like a general region. So so let's say, so example number 7. So you can see, so let's say so consider a solid, with circular base of radius 1. Circular base of radius 1. And then what we're gonna do, we're gonna cut this. So that's a solid. Okay, that's a solid which has a base like a circle. What we're gonna do, we're gonna cut this solid perpendicular to the base. Okay, so we're gonna cut this perpendicular to the base. Once you cut it, the cross section looks like a equilateral triangles. Okay, so parallel cross sections are parallel cross sections perpendicular to the base, parallel cross sections perpendicular to the base are equilateral triangles. What are the equilateral triangles? Triangles with all three sides are the same, right? That's equilateral triangle. Okay, find the volume. Find the volume of the solid. Find the volume of the solid. Okay, so let's try to kind of understand this situation. So what it looks like. So we might need like several figures here. So what it says. So the base is a circle. Base is a circle. Now what we can do, we're going to cut it. We're going to cut it into, so there's a solid, some shape. We're going to cut it into, we're going to cut this perpendicular. So when you cut it, so I'm going to, this is the plane. So I'm going to cut this through this. Okay. So let's say you're going to cut this. So that's a slice. Once you get the slice, what it says, the cross section is a equilateral triangle. So if you look at the cross section, once you cut it, the cross section is a triangle. That's what it says. The cross section is a triangle. Each cross section is a triangle. So we're going to cut it perpendicular to the base. Okay, once you cut the perpendicular to the base, each cross section is a triangle. Okay, I hope it's clear now. So that's the, okay, so each cross section is a triangle. So that's the xth position. That's the xth position. So let's say this is your 0. That's a 0, and this is the y-axis. That's the x-axis going like that. Okay, so you see that the cross section is a triangle. Okay, that's a cross section, but which is an equilateral triangle. So what you want to do is, we can still use the same formula. So what's the formula we're trying to do? V equal the original formula. So it's going from, it's a circle of radius 1. That means it's going to go from -1 all the way to 1. So it's a -1 to 1. And then we need to find the typical area dx. So we use the general formula, like equation number 1. So what we need to do is, we need to find the area of a cross section. Area of a cross section. So and then, so what you need is, you need to find the height, right? It's a triangle. So we need to find this, how much is this height. So we might need like several figures. So I'm gonna draw a view of the circle from the top. So if you look at from the top, this is what it looks like, and this is, that's the 0, and that's where you cut. That's the x. Okay, that's where you cut, and then so what you need is, you need to find this this distance. How much is that distance? So so actually, let's, I'm gonna take this is not y, so I'm gonna take y in the let's take y in the xy plane down there. So that is the y-axis. So y-axis going like that. So that's my y-axis. So if you say y-axis like that, so that's x-axis and that's the y-axis. So so that's the y-axis now. It's easy this way. That's the y-axis, that's the x-axis. So now what you want to do is, we need to find what is this base length, y. So that's that. And then we know that the radius is 1. So and that's x. So we know that x squared plus y squared equal 1, so y equal 1 minus x squared square root. That's the y. Now what we're trying to do is we need to find the area of the triangle. So how to find the area of the triangle? To find the area of the triangle, so and then also we know that this is an equilateral triangle, so things are a little bit easier. So what's gonna happen? So that's the equilateral triangle that we had, and then that's the y coordinate. That's a y. There's a y here, and this is like 60 degree. And what we need to know is the height. How to get the height? We can write a tan here. So we know that h over y equal tan 60. Tan 60 is square root 3. So h is y times square root 3. Right? Y times square root 3. That's the height. So then we know we can find the area of this triangle. Area is what's the area? Half base times height. Okay, so half base times height. So I'm going to plug in that here directly. So that means it is a negative 1 to 1. That's where the x limit goes. It's going from negative 1 to 1. X going from negative 1 to 1. So these are the x limits, negative 1 to 1. And then what you want to do, you want to express everything in terms of x before we integrate. Okay, so let's do it. So we have the area of the typical cross section, that means the area of the triangle. So it is 1/2. The base is base of the triangle is 2y, and the height is square root 3y, right? And then it is a dx problem, because x is changed. It's a dx problem. So you can see that the x and y you can integrate yet. So let's simplify this a little bit, and half get cancelled, so you get square root 3. I can take it out. So negative 1 to 1, and we have y squared dx, but we know y squared equals to 1 minus x squared. Okay, so we can put it there. So it is square root 3 negative 1 to 1 minus x squared dx. Okay, so the goal of these kind of problems are to find the area of the typical cross section. Okay, so for that you might need to use the geometry. You might need several diagrams here, but after you find the cross section, just integrate that. Okay, and then after it's easy, square root 3. This integral is easy integral, is x minus x3 over 3 1 negative 1, or you can go 0 1 multiplied by 2 also. Okay, so that also works. And you know that this is an odd function. So since this is an odd function, actually you can do it either way. Since the top is an even function, you can do double. Yeah, let's do it like that. Or I mean, you can even solve like that, or you can go with the double. So I want to, since I want to show you the trick here, so you can completely simplify and get the final answer. But here you can see that this is an even function, so I'm going to show you the shortcut. So so if you simplify, you get the answer. Or let's erase this part. You can see, since this is an even function, what's going to happen? it's a negative a to a even function, so it is twice the integral of half going from 0 to 1 minus x squared, because this way it is easy. So twice the half, right? Twice the half, because it's a even function. In your even function, you can just go half of it and double. It's only for even functions. You have to go from negative a to a like that. So we have, so it's easy. So you have 2 square root 3 x minus x3 over 3 1 0, because 0. So you're gonna get and once you plug in 0, if you plug in 1, is 1 minus 1/3. So so 2/3. So you end up getting 4 square root 3 over 3. Okay, so that's the volume of the solid. So this is special situation. So what happened here is, so you have some kind of object, and it explain what's the typical cross section looks like. So that means if you have a cross section, it says that it looks like a triangle. So if it's like a triangle, what you're gonna do, and then you try to find the area of a triangle. But this is equilateral triangle, that means all the sides are equal, and then that each angle is 60. So we can use some kind of geometry here. We know that h over y is a tan 60, which is square root 3. So you're gonna get h equal square root 3y, and then we're gonna use that. So it's a half base times height. So that's the base, and this is the height. So you plug in it there. So you get the area, and then you can integrate by its integration go from the x direction from negative 1 to 1. And we also know there's an even function, so we can say twice half of the integral. Just to make easy, because once you put 0, it's easy to simplify, and then you simplify and get the answer. Okay, so this is the end of the section, but this is not the Washer method. This is a general problem, and in the homework there are 2 problems like that, so make sure that you do that. Okay, so thank you. Now in the next lecture we're going to do the cylinders method. So I want to give you an extra credit problem if you want to try. So this is the extra credit problem. Extra credit problem. So let's say find the volume of a right circular, find the volume of a solid, find the volume of a right circular cone. Right circular cone, that means there's a cone like this, the base is a circle, circular cone of with height h and base radius r. So which has the height h and the base radius r. So the radius is r, the height is h. Okay, so if you want to do this, you can do this problem and send me, and you can get some extra credit problems. I might add this to the exam, so let's see, but I don't know that exactly. Let's see how it's gonna work. Okay, so I might add this to the exam, but I'm gonna give you that option. Okay, so thank you. Yeah, so and then you can email me after you do this. So you saw all the work. Okay, so as a help, read example I think 8. Yeah, example 8. It can give you some hint for this. Okay, good.